Okay, guys, next lesson. We're still going to use Q equals MC delta T, but this time we're going to use it to identify an unknown metal. If you recall from last year, we used this for an entire IA. We did 25 trials with 5 different metals. We did this 5 different types for 5 different metals. And so this time I'm just going to show you one example and then you're going to practice. So this is review. So you have to start with 125 grams of water in a calorimeter. Remember, it doesn't matter how many grams of water. I think we used 100 grams when we did the lab, but the problem will tell you how many grams of water you start with in the calorimeter. The calorimeter was our styrofoam cup. Remember, we put a hole in the top, we used a thermometer, all that. Okay, you take the original temperature, the initial temperature of the water. In this case, it's 25.6 degrees Celsius. Then we have our unknown metal. You take the mass of the metal, it's 50 grams, and you heat it up. In this case, it's heated up to 115 degrees Celsius. Last year when we did the lab, we heated it up in some boiling water, remember? And so what we do is that we place the metal into the calorimeter and the temperature of the water rises. Hold on, Pepper wants to say hi. Hey, Pepper. Come here. Say hi, Mama. Say hi. Hi, baby. Say hi. Say hi, everybody. Hi. This is Pepper. And she's beautiful. And she's Mama's baby. Mwah. Okay. Anyways, back to this. So, the metal is placed in water inside the calorimeter. So, remember, the metal's hot, so it's going to make the temperature of the water go up. The temperature is going to go up to 29.3 degrees Celsius, and at the end, both the temperature of the water and the metal are going to be at equilibrium, meaning that they're going to be equal. So both the water and the metal are both going to be 29.3 degrees Celsius. Okay, so now, what do we do next? You have to remember that the heat gained by the water is equal to the heat lost by the metal. And so this is very important. Q of the water equals Q of the metal. Why do you need to know that? Because, of course, you have to go from step 1 to step 2 using this piece of information. Step 1, step 2. You need that piece of information. All right? All right, let's do it. Step 1. First, calculate the heat gained by the water using the specific heat of water. This is the value that they're going to give you in the data booklet. All right, guys, so let's do that. So, step 1. Q of the water equals MC times delta T. Remember, we're talking about just the water. So, what is the mass of the water? 125 grams. What's the specific heat of the water? 4.184 times joules per grams per Kelvin. What is the delta T of the water? Right here, 29.3 minus 25.6. Well, here's the thing. It doesn't really matter if it's in Kelvin or Celsius because the difference is going to be the same no matter what. So here I converted them to Kelvin. So Kelvins cancel. You see, Kelvin, Kelvin, cancel. But if you subtract 29.3 minus 25.6 in Celsius, it still gives you 3.7. So the delta T is still 3.7, no matter what, even if it's Kelvin or Celsius. But Kelvin needs to cancel so that the only units left are joules. Multiply 125 times 4.184 times 3.7, you get 1,935.1 joules. So basically 1,935 joules. That is step 1. Okay, that is going to take us to step number 2. All right, back to the notes. So, step 2, second step, calculate the specific heat of the unknown metal. All right, to do this, you have to take the same formula. Q equals MC delta T. This time we're talking about the metal. So all of this has to do with the metal. Okay, what are we looking for? We're looking for the specific heat of the metal. So I need to do my algebra, and I need to divide both sides by m delta T, m delta T, m cancels, delta T cancels. What do you have? Q of the metal divided by the mass of the metal multiplied by the change in temperature of the metal. This is all metal, 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 metal to get the specific heat of the metal. Yes? Okay, so how do you connect step 1 to step 2? Remember, Q of the water equals Q of the metal. So I'm going to go ahead and write down all my values. Q of the metal is 1,935.1 joules. The mass of the metal equals, what was it? 50 grams. Delta T of the metal, what is it? It started at 115 and it went down all the way to 29.3. So what's the difference? 115 minus 29.3, 85.7. Now, remember, Kelvin or Celsius, doesn't matter. It's just how much it changed. That's how much it changed. So it's still going to cancel, right? Okay, let's go ahead and plug it in then. Q on top, 1935.1 joules divided by the mass, 50 grams, times the change in temperature, 85.7 Kelvin or degrees C. But you know what? We're talking about IB, right? So we're going to say Kelvin. It doesn't matter. So plug that into your calculator. You've got 1935.1 divided by 50 divided by 85.7. 0.45. Rounded to the hundredths place. Joules over grams times Kelvin. Or, same thing, 0.45 joules, grams to the negative 1, K to the negative 1. That's your answer. If you were to look that up, you would find that that is very close to the specific heat of iron. So you would probably find out that that metal is iron. Let's see. Is that it? That's it. Okay. So, lesson number 2 for topic 5. 2 steps. Q equals MC 2 times. Step 1. Calculate the heat gained by the water. Step 2. Calculate the specific heat of the unknown metal.